Hi, so we are continuing this lesson in systems of three variables, and we want to look at a special case. The infinitely many solutions example happens when we got a system where all of our variables just disappeared, and we got an equation down to 0 equals 0, or something like a constant equal to the same number. So if it's like 7 equals 7, 1 equals 1, -5 equals -5, it's because the variables disappeared, and no matter what number you plugged into those variables, they will also always disappear. So we get to an equation that is just always true, like 0 equals 0. Our goal has not changed. We want to get a three variable system down to a two variable system. The way we do that is up to you. You can do that by substitution or elimination. Either one is fine. Now, this is going to take a little bit more patience just because we already know it is an infinitely many solutions example. So to get this down to a two variable system, we're going to need to eliminate a variable. If I look at my equations, I already have one equation that is two variables, x's and y. So if I use the other two equations, I can eliminate z and get a new equation that's x and y. That's just one observation that might make this easier. If I was looking at this problem ahead of time, I would have no idea that it's infinitely many solutions. I'm just told that this is an equation or a system that I need to solve. So I'm going to set up the first and third equation together. So 3x minus y plus 2z equals 6. And x plus 3y plus 2z equals 22. I want to eliminate z's because we want to get another xy equation. To eliminate z's, I'm going to multiply the bottom equation by -1. That would give me a -2z here. So the first equation doesn't really need to change at all. But the bottom one's being multiplied by -1, which makes -x, -3y, -2z equals -22. We see that the z's will eliminate, and I get 2x minus 4y equals -16. Now we have a two variable system. All right, our two variable system is coming from this equation that we created and one of the original equations. You might notice already some things that are similar about these two equations. All right, if I set this up, I can already do elimination. So I would add these together and we eliminate our x's, but we also eliminate our y's and we get 0 equals. The 16 minus 16 is 0, so 0 does equal 0. That's our clue that this is an infinitely many solutions example. So we would not know this automatically, but now we just figured out that it is infinitely many solutions. The way that we write our answer for infinitely many solutions depends on the textbook, really how they decide how this should be written, or just however you feel like expressing that answer in terms of the other variables. So I've written some instructions down here at the bottom that say that the final answer should be written in the following way, where x, y, z is written as x equal to some expression about z, y is equal to some expression about z, and z is any real number. All right, what we need to do in that case is express x in terms of z. Our goal really is to express each variable in terms of one of the other variables. So we need to express x in terms of z. Now I've learned that that's somewhat an abstract concept. All right, writing x in terms of z doesn't mean what we think it does sometimes. At least the math understanding of it doesn't always translate. So what we're trying to say is write an equation where x is equal to something about z. How is x related to z? That means that we need an equation of only x's and z's. If I look at the equations that we have currently, none of them are only x and z's, but we can create one. So if I put the first and third one together, I could eliminate the y's, and then it's only x's and z's. So I'm going to take that 3x minus y plus 2z equals 6 again, and put it with the third one again, which was x plus 3y plus 2z equals 22. And we want to eliminate the y's this time. That's going to allow me to get an equation that's only x's and z's. So to eliminate y's, I'm going to multiply the top equation by 3. That makes 9x minus 3y plus 6z equals 6. Nope, not 6. Equals 18. Got to multiply everything by 3. And now if I put that with the third equation, we can eliminate those z's. Sorry, the y's. So we're eliminating y's. Negative 3y plus 3y is 0y. But we do get 9x plus x, which is 10x, plus 8x, or 8z equals 40. This is one equation where we have x's and z's. Our goal is to express x in terms of z. So we would solve for x. That way we can write that expression out. So this will be 10x is equal to negative 8z plus 40. If I divide by 10, that's negative 8 over 10, which reduces to negative 5/4 z plus 4, since 40 divided by 10 is 4. Now I have an expression that says x is related to z in this way, negative 4/5 times z plus 4. All right, we also need to express y in terms of z. To do that, we would have to have an equation that's only y and z. So I'm going to need to eliminate my x's this time. So I'm still putting the first and third one together, but I could choose any of the equations I want. So 3x minus y plus 2z equals 6, and x plus 3y plus 2z equals 22 again. I'm going to eliminate the x's this time so that I have an equation that's only y and z. That is easiest by multiplying the bottom one by negative 3. I'm still trying to organize this work in a way that's not confusing, but I know that it takes up a lot of space. So generally, I'll try to give you as much room as I can to solve these types of equations. All right, so we've multiplied the bottom one by negative 3. That eliminates our x's. When we combine our y's, we get negative 10y. Combine our z's, we get negative 4z equals negative 60. And we want to solve for y this time. We're solving for y because we're trying to express y in terms of z. We want to say, how is y related to z? So if I add 4z over, we have 10y equals 4z minus 60. Divide by negative 10 would make negative 2/5 z plus 6. Now I have an expression that says x is related to z somehow, y is related to z somehow, and z is just z. So we could write our solution as, when we say x, y, z, we're saying x, y, z is equal to negative 4/5 z plus 4. Y is related to z as negative 2/5 z plus 6. And then z is just z. That's a typical way to write this, but really it's up to your instructor or your textbook, whatever resource that kind of gives you the guidelines. Sometimes we express all of the variables in terms of x. Sometimes we could express them all in terms of y. It's just generally not as common. And then a lot of times we express them in terms of z, like we did today. Now, another way that we can do this, and this is what WebAssign does, it will say let z equal t. In that case, then we would say our x, y, z is equal to negative 4/5 t plus 4, negative 2/5 t plus 6, and z is just t. So everything has been written in terms of this t, and we are stating already that z is equal to t. It's a little bit different, but that is something that you might run into when you see this on WebAssign, so I wanted you to be aware of that. All right, so there are a few more examples for you to try on your own. You can go ahead and practice them now. So here are the two examples, and then in the next video, if you want, you can see me going over these two examples.